In lesson 106, we're going to talk about inscribed polygons and circumscribed polygons. The first, what an inscribed polygon is just a polygon inside of a circle. So we have a pentagon here inside of a circle, and its endpoints meet on the circle. So example 1 wants us to find the perimeter of the pentagon. So I'm going to draw the pentagon. All right, something like that. And I'm going to redraw what we have here. So right now, we know the radius, the radius basically is 4. Now, we can actually know, so we need to find x. The goal is to get to x and multiply it by 5 because all the sides are the same to find the perimeter. This is n. We can actually know what n is because if you remember how to find a central angle, this is known as a central angle. And to find a central angle, you simply do 360 divided by a number of sides. So in this case, we have 5 sides, so it would be 360 divided by 5. So n would be 72 degrees. So we can know what our central angle is. Now, how can we figure out this length right here? Well, what I'm going to do is I'm going to redraw this triangle. We know that this is 72. We know that these sides are 4, so it's an isosceles triangle. I can actually create a little right triangle right here that looks something like that. I know what this angle is. This angle would be cut in half. 72 would be 36. So, making it look like one triangle. That's a 36-degree angle. We need x. So, we're going to do sine because we want opposite x over hypotenuse 4. Multiply the 4. 4 sine of 36 gives roughly 2.35. Now that's only half of x, so we need to multiply that by 2 to get the whole side length, because remember it came all the way out here. So we're going to multiply by 2, and we get roughly 4.7. 4.7. That would be one side length of the pentagon. So now multiply by 5 because there's 5 sides, and we get roughly 23.51. 23.51, or it says to the nearest hundredth. It's actually 50. The units, yeah, just units. And that's how you do inscribed polygons. So now let's look at a circumscribed polygon. In example 2, I'll try to draw this as best as I can. It gives us a circumscribed. All right. Yeah. So we have a circumscribed hexagon. So the shape is outside the circle. So that's called circumscribed. Now it gives us that this height right here is 10. Or yeah, it gives us the radius is 10. And it wants us to find x. So once again, I'm going to break down this hexagon. Wow, that's a big hexagon. Jeez. Perfect. Okay. And we have this side is 10. Once again, we can know what this degree is by doing 360 divided by number of sides, which in this case would be 6. That's how we find our central angle. Using that formula, 360 divided by number of sides, which is 6. So each central angle here is 60. So if I created a right triangle right here, I know my height is 10. I know I'm looking for x. And I know that this angle right here would be 30 degrees because I cut 60 in half. Because we made a triangle. So that's 30. So how do we get from long side, right now we have the long side, the 60 degree side, to the short side? You can use trigonometry. I'm going to use 30, 60, 90 principles. Remember, to get from here to here, we multiply by radical 3. So to get from long leg to short leg, we're going to divide by radical 3. And remember, that is not simplified. Can't have a radical in the denominator, but we're actually going to make it into a decimal. So I'm going to do 10 divided by radical 3 and get roughly 5.77. So 5.77. Once again, that's only half for x. So I need to multiply it by 2 to get the whole side. Roughly 11.55. I'll put it up here. 11.55. So then I need to multiply that times the number of sides, which would be 6, and get roughly 69.3. They want it rounded to the nearest hundredth, so they do 69.24, whatever. You get the idea, and it'd be inches cubed, or not cubed, inches, since we're just finding perimeter. So that's how you do inscribed and circumscribed polygons.